Accessibility checkers told me my textbook had 980 contrast errors. I fixed them and accidentally broke my book's color system. This is Maggie from Design Code Debug Repeat. Welcome to the channel. As I mentioned in the last video on tags and accessibility, colleges are working on modifying their online course materials to follow the Web Content Accessibility Guidelines, abbreviated WCAG, 2.1 AA standard because of new accessibility regulations that require public institutions to meet the WCAG 2.1 AA standard by April 2026. And again, this video isn't just for faculty. If you're a programmer, you need to know about accessibility standards. People use software, so software needs to be accessible to people. When I ran accessibility checkers on my materials, some of my PDFs were flagged for poor text contrast. I know what contrast is. It's the difference between elements like background and text that makes them distinguishable from each other. But I had a lot of questions. How is contrast measured? What is sufficient contrast using that measurement system? And how do I fix text with poor contrast? I was able to solve the issues in my courses without having a clear answer to any of these questions, but not without collateral damage. So I did a deep dive, and I want to share the answers to these questions with you. I think it will save you a lot of time and trouble. Let's start with a brief overview of the standard RGB color space. There are chapters in this video, so you can skip to the next chapter if you already know how colors are represented in software. Colors are composed of red, green, and blue components. It's not the only way you can think about color, but it's the relevant way for this conversation about contrast. What you're seeing here is an example of the font color picker in Microsoft Word. I've selected some red text, and the color picker is showing me the exact color of that text in several different ways. One of those ways is as the three separate red, green, and blue components of the color. Each of these components is an integer from 0 to 255. This color red is 181 red, 0 green, 0 blue. If I wanted to make it more purple, I'd add some blue. I'll put 181 in the blue box, and you can see the new color is purple. If I wanted to make it more yellow, I'd put blue back at 0 and add green. I'll put 181 in the green box. Now I have a sort of chartreuse color. If I want gray, I'll need equal amounts of red, green, and blue. I'll make them all 181. There is a gray continuum from black, 0, 0, 0, to white, 255, 255, 255. Perception of color varies so much within the population that the WCAG standard is to require contrast that is independent of color perception. So rather than having a list of rules such as never put red text on a green background, the standard is to have a sufficient contrast between the text and the background so that it can be read regardless of color perception. So how is that contrast calculated? There isn't a simple way from a color's RGB values to immediately know if two colors will have sufficient contrast. Contrast in the WCAG standard is defined according to a color's relative luminance. Relative luminance measures how bright a color appears to the human eye. Bright colors have values close to 1, and dark colors have values close to 0. What you're looking at now is the definition of relative luminance in the WCAG Guidelines glossary. You can see it's a little complicated. Let's calculate the relative luminance of my red color. Now, don't worry. You never have to calculate this by hand, but understanding how it works can be empowering. We'll need to work from the bottom of this definition up, just because that's how it's written. So first we'll calculate R, G, and B. RS, RGB, which means the red in standard red, green, blue, is R 8-bit divided by 255. So R 8-bit is 181. So 181 divided by 255 is, we'll round it off, 0.7098. Now, green and blue are easy because they're 0. 0 divided by 255 is still 0. Moving up, we plug those numbers into the next part, which is an if our sRGB is less than 0.04045. It isn't. So we'll go to the else. R equals RS RGB plus 0.055 divided by 1.055, quantity raised to the 2.4 power. 0.7098 plus 0.055 divided by 1.055 raised to the 2.4 power is, rounded, 0.46207. Now, green and blue are easy, again, because they're both 0. But 0 is less than 0.04045, so if they weren't exactly 0, we'd do this other calculation. We'd divide by 12.92. With our values for R, G, and B, we can now calculate the relative luminance of this red color at the top of this box. Relative luminance is 0.2126 times R plus 0.7152 times G plus 0.0722 times B. 0.2126 times 0.46207 is 0.09823. And green and blue are again 0. So when I add them all together, I still have 0.09823. I've calculated the relative luminance of my red. What good is that? That's the value that's used to determine contrast, which is a ratio. Let's jump up in this document to Success Criterion 1.4.3, Contrast Minimum. For level AA, it reads, the visual presentation of text and images of text has a contrast ratio of at least 4.5 to 1. And being proactive, if I scroll down to Success Criterion 1.4.6 Contrast Enhanced for level AAA, a contrast ratio of at least 7 to 1. Why wouldn't we shoot for that one? But how do we calculate it? If you're curious how the standard works under the hood, let's calculate it once. If you're just trying to fix your documents, feel free to skip ahead. If I click on the link Contrast Ratio, I'm brought to the contrast ratio section of the glossary. That is L1 plus 0.05 divided by L2 plus 0.05, where L1 is the relative luminance of the lighter color and L2 is the relative luminance of the darker color. So my red color will have a different contrast ratio depending on the background. Most of the text in my book has a white background, which has a relative luminance of 1. So I have 1 plus 0.05 over 0.09823 plus 0.05, which is 7.0835, which would typically be written 7:1. That meets the AAA standard. But if I put it on a black background, then I have 0.09823 plus 0.05 divided by 0 plus 0.05, which is 2.96 or 2.9 to 1. That meets no standard. Okay, now fortunately there are tools that will do that work for you. This is AudioEye's Color Contrast Checker. There's a link in the description. Let's see how good my calculation was. On the left, I can enter the foreground color. See the little hashtag before the number? That means the number is being shown in hexadecimal. That's the base 16 number system, and it's just a shorter way to show an RGB color. Back in the word color picker, there was a little hex representation of the color under the RGB values. Our red in hex is B50000. I'll type that in. And the background color is already white, FFFFFF. And it shows me 7:1. My hand calculations were right. This color on a white background meets the AAA standard. So, how do you fix text documents that have contrast issues? Let's go into Word. This is one of my textbooks, and unfortunately, it has poor text contrast. When I'm writing up programming examples, I use the colors that my students will be seeing in the development environment. So in this book, you can see my code example, or maybe you're finding it hard to read. It's using the default colors in the integrated development environment my students write code in. And some of those colors have insufficient contrast against the white background. I'll change the colors here in the book. Fortunately, there is a way to change those colors in the development environment too. In Word, I will go to the Review tab, click on Check Accessibility and then Check Accessibility, and after it runs, there is a Quick Fix box in the upper right that says 332 dark green color texts have poor contrast. If I click the Review Issues button, it brings up all of the text it found with poor contrast, and I'm given 3 colors that I can choose from to replace that text. If I scroll through the examples, they definitely look like examples of text that would be colored green in the integrated development environment. So what I did initially was I chose one of the offered colors, clicked Apply to Selected, and then went on to the next issue, which was the next color with insufficient contrast. This is much quicker than coloring each bit of text appropriately by hand. But for some reason, when I was done, I found that all of the code hadn't been colored correctly. Some code that should have been orange, like the word import here, was black. Some text that should have been red, like this text preceded by hashtags, was black, and some was green. So I did need to repair it, and I'm not sure why. It could have been a mistake I made initially. So I did redo this all by hand, but redoing it gave me the opportunity to think about what colors I really wanted substituted in, and it allowed me to get all of the code examples up to the AAA standard rather than the AA standard. Choosing an offered color and choosing Replace All gave me a quick fix that met the contrast standards, but I wanted to make more intentional choices. So I wondered, in MS Word, how can we use the Quick Fix option but get a more intentional result? In the Quick Fix, I'm given the option of 3 colors, but if I right-click on one of those colors, I have no way to change it or even get more information about the color, like its RGB or hex value. So the way to do this with more intentional colors is, once the Quick Fix has identified an unacceptable color, first decide what color you want it to be. I don't recommend accepting a lot of quick fixes that might make your document pass an accessibility checker, but might take away some of the meaning and intentional choices you've put in. Were you communicating something only with color? You might need to rethink that part of your document. If you are going to replace the colors, first choose the color you want to use as a replacement. You've got the contrast checker to help you find a color that meets the AA or AAA standard. Then find some of that colored text in your document and find what color it is by going to Font in the Home tab, click on the Font Color pull-down, choose More Colors, and select and copy the hex color. Now choose Replace from Editing in the Home tab, and if that dialog box has a More button in the lower left, click More. Then click in the Find What box and click the No Formatting button at the bottom to clear any formatting. Do the same with the Replace With box. Now click in the Find What box, click on the Format menu at the bottom, and choose Font. Click on Font Color, More Colors, and paste the color we want to replace into the box. Now do the same for Replace With, except this time type in the hex of your chosen color. I've chosen a darker green here, 0060000, because that color has a 7.8:1 ratio. And then choose Replace All, if you're confident that you want to replace all of the color. That color is only in my document where there is code, so I'm clicking Replace All. And when I check, I can now see that the green has been replaced with a much higher contrast, darker green. I wish I had known more about color contrast before I went through the accessibility checker with this book initially, because it took me a day to clean up the mess that I had made clicking the Quick Fix button. And that was after I researched contrast, decided I wanted to meet the AAA standard, and chose new colors. If I'd known then what I know now, I could have made these changes in minutes. Fortunately, I know it now, before I edit my next book and before I write up lecture notes for next week's classes. I hope this information helps you create accessible documents, and I hope it helps you avoid any messy fixes for existing documents. Best of luck to you making your course materials accessible. It is important work and worth the time you're putting in. In the end, your materials will be better for everyone. Thanks for watching, and take care.